Hi guys, it's Miss Griffin. I just wanted to let you know that we should be looking at the August 2017 exam. This is the one that we were working in last class. We are going to continue in this. I'm sorry I'm out today, but I do have a training, so unfortunately I'm not here to teach you directly, but we can watch it through the video. Alright, so flip with me. I think we left off for question number 6. Alright, so here's question number 6. This is something you could definitely do in your calculator. I don't have a calculator here, so I'm actually going to go through how to do it by hand, just in case this is a short answer question. So it's always good to know how to do this stuff by hand, just in case, again, it comes up as short answer. If you were using your calculator, you would take each of these individually and type them in as a relation. So instead of as a function, you would enter it as a relation. So it would be the graph, and then menu, choice 3, entry, edit, and then use a relation. And then once you did that, you would go to analyze, look for the focus, and look for the directrix, and then you want to find one that matches. But now we're going to actually do this by hand, so that if it's short answer, you can figure that out yourself. Okay, so there is a formula that represents the equation of a parabola, and remember that it starts with 4p, parentheses y minus k equals x minus h, parentheses squared. Okay, so that is something you would have to memorize. So we're going to draw a little sketch here that's going to be helpful to us. We want to start with a little xy axes. And we want to plot the point 0, negative 1 to represent the focus. So that's over 0, down 1. And also the line that represents the directrix. Up 1 on the y's, so that gives us a directrix here. If you recall, a parabola looks like this, or it looks like this, and there's a point at the bottom or at the top, depending on which direction the parabola is facing, and that represents the vertex. Okay, so we need a vertex so that we can come up with our h and our k. The vertex has to be smack dab in the middle of the directrix and the focus. So remember, this was down at negative 1, this was up at positive 1. So the number that's smack dab in the middle is, in fact, 0. This parabola has to be drawn pointing downwards because it can never cross over that directrix that we have here. Okay, so we just found the coordinates for our vertex. Our vertex is located at 0, 0. The next thing we need is the p-value, and p is the distance from the directrix to the focus. So the distance between these 2 points. Well, this is at 0, this one's at negative 1, so the distance here is negative 1. If the parabola points downwards, p is negative. If it points upwards, p is positive. So we're going to plug in what we know. We've got 4 times negative 1, y, minus the k value. So it's like x, comma y, h, comma k. Alright, so k is 0, so y minus 0 equals x minus the h was 0, parentheses squared. So we're going to simplify this here, makes negative 4, times, well, this is just y, right, this piece here, just y, so 4 times y equals, and again, this is just x minus 0 is just x, squared. And so now this is negative 4y equals x squared. That should be an answer, choice number 2. Okay, we're actually going to skip number 7. This question has come up twice in the last probably 6 or 7 administrations of this exam, and it's just not something that is worth spending our time on. So we're going to flip over to question number 8. It says, what are the zeros of p of m equals m squared minus 4 and times m squared plus 1. So here's our equation. It's asking us for the zeros. So we want to take and factor and then solve if we can. So we have m squared minus 4 times m squared plus 1. So we want to look at this, the first pair of parentheses versus the second pair of parentheses, and say to ourselves, can we factor either of them? Remember, if you have a perfect square, 2 perfect squares, and a minus sign in between them, you can factor it. Okay, so this breaks off into m plus 2 and m minus 2. And then this one, this is perfect, so is this, however, it's a plus sign. So this cannot be factored, it has to stay. And then remember, when it's all set equal to 0, we have to t-chart. switch the sign every time when you pull it out. So m equals -2, m equals +2. And then this would be m squared equals -1. But we have to get the squared away, so we're going to square root both sides. Remember that it's always a plus and a minus when you square root. So we have m equals plus and minus, well, this is technically the square root of +1 and square root of -1. Square root +1 is just 1, but square root -1 is super special. Square root of a -1 is always I, remember. So this is actually 1i, plus or minus 1i. And so we've got -2, +2, plus or minus I, which gives us choice 4. Okay, next one says the value of a new car depreciates over time. Depreciates, remember, means goes down, decreases. Greg purchased a new car in June 2011. The value of the car after t years can be modeled by this equation. And again, t is the number of years. What's the average decreasing rate of change per year of the value of the car from June 2012 to June 2014 to the nearest $10 per year? So this problem is actually going to take us a little bit of work, so get ready to dive in here, okay? I'm just going to erase the work that I have from up above, just so that I have a little bit more space. So we're going to have to solve this equation first to figure out what the v is, the value, when we have June 2012 and June 2014. Remember that we got the car in 2011, so by the time we hit 2012, we've only had it for 1 year, so t equals 1, time in years. And then in 2014, we've now had the car for 3 years. So we need to figure out the value of the car after 1 year and after 3 years. And then we have to find the average rate of change. Average rate of change, if you recall, is change y over change x. So first step, find out your values. Second step, find out your changes. Third step, find out change y over change x. Holy moly, we can do it though. All right, so step number 1, we are going to plug in what we know, log of 0.8, or log base 0.8 of v over 17,000 equals 1 year. So to solve this, if you remember, we've got that loop method. Base stays base, swap the other two, so that base of 0.8 stays. It's no longer attached to the v over 17,000, but raised to the power of 1 equals v over 17,000. 0.8 to the first power is just 0.8 equals v over 17,000. So we're going to cross multiply this real quick and get a v value. So this gives us 13,600. So I'm going to make a little table over here because this is going to be our second step. We can't fully fill it out, but we can fill out part of it. After 1 year, we had a value on the car of 13,600. Isn't that kind of crazy? It started out at $17,000, and now after just 1 year, we're down to 13,600. All right, so we found the value when t is 1, but now we need to find the value when t is 3. So I'm going to repeat this process. We've got log base 0.8 of v over 17,000 equals not 1 anymore, but that 3 for 3 years. So base stays base, that means 0.8 stays, and switch the other two, so the 3 becomes an exponent equals v over 17,000. You can just put this over 1 and cross multiply right away if you'd like. So we have v equals, when I cross multiply these in my calculator, everyone should do that. So when I put them in my calculator, I got $8,704, and so I just came over here to my step 2 and put in, after 3 years, we had a value of $8,704. So now what we're going to do is find our change in x and our change in y. So the change from 1 to 3, well, that's super easy. It's a change of 2. change from 13,600 down to 87,000 or not 87,000, 8,704. I wish my car was worth $87,000. Okay, so find that change. Well, you just do top number minus bottom number, but notice that it's a decrease, so it's going to be a negative. Top number minus bottom number, 4,896. Okay, so we've got step 1 done, step 2 done. Now we just got to do change y over change x. That's step 3. So step 3 is our change in y's over our change in x. So negative 4,896 divided by 2. Go ahead and type that into your calculator if you'd like, or be Jake Mikens and do it in your head. And we've got 2,448, but it is a negative. And it says, what's the average decreasing rate of change? So they're indicating that it should go down by a certain value each time, each year, $10 per year. So this 448 is very close to 450, which is choice 3. All right, so we are moving on to number 10. Uh-oh. Okay, figured it out. All right, so number 10, we've got iridium. I-92 is an isotope of iridium. I don't even know if that's how you say it. And it has a half-life of 73.83 days. So this is important to us. It means that every 73.83 days, the substance mass gets cut in half. So if we start with 100 grams, after 73.83 days, we get 50 grams. Oh, and guess what? We begin with 100 grams. Awesome. The number of grams A of this substance present after T days would be present. I meant to say present. Present. The amount of the substance present after T days would be this equation. Which equation approximates the amount of iridium 192 present after T days? So what we want to do is actually separate this out. So we've got, this is equivalent to saying 100 times 1/2 raised to the 1 over 73.83, all raised to the t. And the reason I said that these two equations are equivalent to one another is because this is technically t over 1 times 1 over 73.83, right? But we just combine by multiplying straight across to make it into one fraction. So all I've done is separate it into two fractions. I just didn't put t over 1. Okay, so now I want to figure out what this piece is in my calculator. So very carefully, you're typing in 1/2 caret, so like your little raised to, and it's raised to the 1 over 73.83. Okay, so in your calculators, go ahead and type that in, please. So when we type this in, we should have 0.990655551. Your calculator might have chopped it off a little early, and that's okay. But then this number would get plopped in here, all still raised to the t. And so now I want to find one that's very similar, and that is choice 3. So again, all I did was took the exponent that they gave us originally, I separated it into its two fractions, numerator over 1, denominator under 1, and found out what 1/2 raised to that power was. I don't know why it keeps doing this. All right, number 11. This is actually a question I really like. The distribution of diameters of ball bearings made under a given manufacturing process is normally distributed. So that means that we should be thinking of a picture that looks like this, with a mean of 4 centimeters and a standard deviation of 0.2 centimeters. What proportion of the ball bearings will have a diameter less than 3.7? So 3.7 clearly falls to the left of 4. And if we want to be less than that, then we're going to shade to the left-hand side. I want to figure out the z-score for 3.7. So 3.7 z-score. Z-score, remember, is value minus mean over standard deviation. So we've got z equals 3.7, the given value, minus the mean of 4, divided by the standard deviation 0.2. Take a second to type that whole thing into your calculator. So I found that it's negative 1.5 standard deviations to the left of the mean because it was a negative. And we said that that's as far as we can go, 3.7, meaning we can only go up to negative 1.5 standard deviations away. So I'm going to make this my upper bound. My lower bound is way over here on the left. Technically it's negative infinity, but we can't type that into our calculator. So our lower bound is going to be a big number, but we're not going to be obnoxious about it, negative 99999. So when I'm saying lower bound and upper bound, this means that we're going to do a normal CDF in our calculator. If you recall, that's menu 6, 5, 2. So you're going to have to do this on your calculator right now, menu 652. Your lower bound is right here, negative 99999. Upper bound is negative 1.5. Leave everything else the way that it is in the calculator. Hit enter and find your answer. So at this point we can pause the video so that you can type it in your calculator, find your answer, and then hit play when you're ready to check in. So your calculator should have given you choice 1 as your answer. Number 12. A polynomial equation of degree 3 p of x is used to model the volume of a rectangular box. The graph of p of x has x-intercepts of these numbers. Which statement regarding p of x could be true? Okay, so we've got 4 options here, and then it looks like in our answers we have 2 options that are correct each time. Okay, so we want to figure out which ones are correct first, and then we want to figure out what we can do in terms of choosing our answer. So I'm going to start by just sketching this. Sometimes the sketch is helpful, other times it might not get us anywhere, but we're going to try it. So x-intercepts of negative 2, so that's here, positive 10, and positive 14. Now I want to think about how I would write this equation. So if x is negative 2, then remember in parentheses it becomes x plus 2. Okay, and then in parentheses this positive 10 now becomes a negative 10. And same with positive 14 becomes negative 14. So the only one that has the positive and negative pieces correct is part B, but it says that it's a negative out in front. So let's talk about how that could occur. Remember, if you have a third degree polynomial, your ends are opposites. So they literally go in opposite directions. So it could go something like this, or it could go something like this. So I'm noticing if I want to choose this choice, it has to go downward. So let's see if this can actually happen. This end would shoot up here, this end shoots down here, because overall it makes that downwards trend. I know this is going upwards, but overall, finally we're going down. Okay, so I'm going to connect these and hopefully it works out. Yes. Okay, so it looks like we could choose choice B as a true statement. We definitely cannot choose choice 1 because these signs are not correct. Okay, so choice A has to be out. So that actually eliminates choice 1 and choice 2. It says the maximum volume occurs when x equals 10. Now you could totally type this whole equation into your calculator and see what the graph looks like. Menu zoom fit probably would be your best option. But we can also just look at this algebraically. So if this is our equation, y equals negative, and then all those parentheses, if x is 10, that would give us the following. Y equals negative, 10 plus 2 is just 12, 10 minus 10 is 0, 10 minus 14 is negative 4. 12 times 0, well, that is 0, times negative 4 is, wow, again, 0, with a negative, which is just 0. So we're saying right here that when we plug in 0, or when we plug in 10, the volume is 0. Is that the maximum volume? Heck no, that's the smallest volume in the world, so we can't choose choice C. If I did type this equation in, I could figure out that the max volume of the box is approximately 56, because max volume is the highest volume we have. So I type this into my calculator. I find the max point by analyzing, and this happens at 12.1, comma 56. So choice B and choice D gives us the answer of 4. When we look at number 13 here, it says which expression is equivalent to this right here, where x cannot be 1/2. So we're going to do a little bit of long division, you guys' favorite. Gonna try to scroll up if possible. Okay, so we've got this whole numerator underneath our division bar. But I'm actually noticing as I write this, I have an x to the third. I don't see an x squared. So I actually want to erase this and write 4x to the third plus 0x squared, then plus the 9x minus 5. So whenever you're missing a variable, you actually want to fill it in with a plus 0 of that variable to whatever power you're missing. And then we have 2x minus 1 over here. So here's a process. You guys love it. I know it. And so we've got to figure out how to make 2x into 4x to the third. So obviously 2 has to be multiplied by 2. X needs to be multiplied by x squared. Then we think about distributing it back through. Okay, as you distribute, change the sign. So 2 times 2 is 4. X times x squared is x to the third. It gives us a positive, but we switch it to a negative immediately. Okay, then when I do this 2x squared times a negative 1, that's a negative 2x squared, but now I want it to be a positive 2x squared, because swap the sign at the end or at the beginning, it doesn't matter, but you have to swap the sign every time. These cancel, which is a good thing. 0x squared plus 2x squared is 2x squared. Carry down the 9x. Now you're asking yourself, how can you make 2x into 2x squared? So 2 does not need to be multiplied by anything, but x needs to be multiplied by a positive x to make x squared. Distribute it back through. Write down what you get. But then go back through and change the sign. So minus and then a plus. 2x squareds cancel. 10x. Carry down minus 5. Ask yourself, how do you turn 2x into 10x? Well, it needs to be multiplied by 5. Positive. So this gives us 10x minus 5, but then we swap the signs. These cancel. Ooh, and so do these. So there's 0 remainder. So our answer here should be 2x squared plus x plus 5, which is choice 1. Next one is also a little bit of work, but we can definitely do this. It says the inverse, remember that means switch x and y. Inverse of this function is blank. So remember that f of x is the same thing as y. So I'm going to start by just crossing it off there, changing it to a y. So we've got to physically switch the letter x with the letter y. So this is now x equals y plus 1 over y plus, nope, not plus, y minus 2. Notice how this side's a fraction on the right, and so this left side also needs to turn into a fraction. From here, we're going to cross multiply. So we have x times y minus 2 equals y plus 1. I want to distribute this so that I can get the y outside of those parentheses. So now we have xy minus 2x equals y plus 1. And when I look at this, I notice that there's a y term here and a y term here on different sides of the equation. So I want to get them to one side. I have to pick a side, and I'm going to choose the left, just because that's where y normally is located. So I'm going to subtract y away. And now we have xy minus y minus 2x equals 1. But this 2x has to go because these are the only y terms. So I have to move 2x to the other side. So I'm going to add 2x to both sides. So we have xy minus y equals 2x plus 1. We're getting there, guys. Almost done. I notice here that I have a y and a y, so that means there's a GCF of y. Okay, so I'm going to pull out a y, write down what's left over, still equal to 2x plus 1. So that whole write down what's left over, well, I take this term divided by y, take this term divided by y. Because the GCF, remember, you do division of whatever you pulled out. So this first one that gets divided by y right here, y's cancel, and we're left with just x. So we have x minus, we need a placeholder for that second set of terms. Even though they cancel, we need that placeholder of 1. So now I'm going to get y alone. This is our last and final step, get y alone. So to get y alone, we've got to undo the multiplication that's happening by division. These cancel, so now we have y equals 2x plus 1 over x minus 1. Choice 2. Alright, so we are on our last question on this page, number 15. Which expression has been rewritten correctly to form a true statement? So you'll notice that on each one of these choices there's an equal sign somewhere in here. And so what we want to do is figure out how to make one side equal to the other. Okay, so this is going to take a little bit of work. I know a lot of these have been taking a little bit of work, and I keep saying that, but unfortunately sometimes that just is what it is. Okay, so we've got this on the left-hand side, and I'm going to expand that to hopefully make this. Okay, so we're going to start by taking that x plus 2 squared and writing it out twice. If you need some scrap paper for this, go ahead and grab some from the shelf that is underneath the calculators. And then we have plus, I can just distribute this 2 right away. That's easy enough. So plus 2x plus 4 minus 8. And my hope is to make it into whatever this is when distributed, x squared plus 6x. Alright, so we're going to double distribute right here. I want you to take a minute to do this on your own, combine like terms on the left side, and see if it's equal to the right. Okay, so I'm going to do it on the video, but you should still be doing it on your own. I'm not going to talk through it because it's easy enough for you to do. So when I did this, I actually found the left side to be equal to the right side. So I'm going to choose choice 1, but I do want to just show you why choice 2 or some other choice does not work out. So I'm going to look at choice 2, just again so that you can see. Even if you find your answer right away, you should always double check to see that the other answers are not true. So when I look at choice 2, I've got the left-hand side, which seems as though everything's distributed, but the right-hand side definitely is not. So I'm going to write out that x plus 3y squared twice. And then it looks like it gets multiplied by x minus 2 squared, so that gets written out twice. So I'm going to do the first piece, and then I will do the second piece. Okay, so the first one, I'm distributing x squared plus 3xy plus 3xy plus 9y squared. This whole thing still gets multiplied by whatever I get when I distribute here. Alright, so I'm going to start by combining some like terms. And then what I have to do is distribute everything here to every piece over here. So we've got x to the fourth, it looks like, minus 4x to the third plus 4x squared. Then I do the same thing with 6xy gets multiplied by each piece. So this would be plus 6x to the third y minus 24x squared y and plus, I'll write it over here, 24xy. And then last one, I'm going to distribute 9y squared to each piece. So plus 9x squared y squared minus 36xy squared and plus 36y squared. And it's very clear that this is not equivalent to what's on the left side over here. Okay, because there's no like terms that can be combined. Alright, question 16. A study conducted in 2004 in New York City found that 212 out of 1,334 participants had hypertension. Kim ran a simulation of 100 studies based on these data. The output of the simulation is shown in the diagram below. At a 95% confidence level, the proportion of New York City residents with hypertension and the margin of error are closest to blank. So, there is this formula that you guys had memorized. It's p hat plus or minus 2 times the square root of p hat times 1 minus p hat all over n. Okay, so p hat represents a sample proportion. So once we have our p hat, we can answer part of the question. P hat, again, is your sample proportion. Don't know why it's on the marker. P hat, we've got 212 people out of 1,334. So if we get this as a decimal, this is 0.1589. So now we have 0.1589 plus or minus 2 times the square root, fraction under the square root, 0.1589 times 1 minus 0.1589 all over n. N is the number of people that were sampled. So there were 1,334 participants, so that's the n. So what's happening here is this p hat represents our proportion, and this 2 times the square root represents the margin of error. So this number is very, very close to 0.16. But then we have to figure out what this number is in your calculator. So I want you to take a second and type it in just as I say it to you. You're going to type it in on your calculator. So you're going to start with 2 and then times square root. Once you've done that, I want you to hit Control Divide to pull up a fraction. So now your calculator looks like this. 2 times square root with a fraction bar. On that numerator, you're going to type in that 0.1589, parentheses, 1 minus 0.1589. Close it up. Then hit the down arrow so that you can type in that 1,334. Okay, so you should have this typed into your calculator, and you're going to hit enter so you can find out what your answer is right here. 0.0200018, blah, 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 whatever your calculator says. And so this represented our proportion. This represents our margin of error. Okay, so margin of error very close to 0.02, proportion 0.16, so that gives us choice 2. Okay, next one says, which scenario is best described as an observational study? Okay, remember there's observational study, there is an experimental study, and then there's just asking a survey of people. So we have to read through each one, figure out which one is best described as an observational study. For a class project, students in health class ask every 10th student entering the school if they eat breakfast in the morning. So you are asking people a question. This question is whether or not they eat breakfast in the morning. You are surveying every 10th student. Okay? Next one says, a social researcher wants to learn whether or not there is a link between attendance and grades. She gathers data from 15 school districts. Okay, so that might look like we're observing the data that we're gathering to talk about attendance and grades and the relationship between them. Okay, so let's pause there for a second. It looks like it's going to be potentially good. Next one says, a researcher wants to learn whether or not there is a link between children's daily amount of physical activity and their overall energy level. During lunch at the high school cafeteria, she distributed a short questionnaire. The questionnaire is a survey. Next one says 60 seniors taking a course in advanced algebra concepts are randomly divided into 2 classes. One class using a graphing calculator all the time, while the other class never uses a graphing calculator. A guidance counselor wants to determine whether there's a link between graphing calculator use and students' final exam grades. So when we do this, the random selection or the random assignment and the treatment of calculator versus no calculator that was imposed or forced on the people means that this must be an experiment. And so the only one that's truly an observational study is choice 2. Flip it over when you're ready. Ooh, look at this pretty thing. We've got 2 graphs, 2 equations, and we have to figure out which one has the greatest amplitude. Remember, amplitude is the change from your midline to your maximum. So again, midline to the maximum is your amplitude. Amplitude is also the number in front of your, oops, I should have written in front of your equation. So when I look at this first graph, it looks like the midline would be smack dab in the middle here. The change from the midline up to the highest, so this is up at 7, this looks like it's up at 5. Change here, amplitude is 2. Okay, gotta find the next one. Midline, well, it's a little tougher to see, so I'm gonna go from the highest to the lowest, count how much that is overall, and then cut it in half. So this is up at 3, down at -5, so that's a change of 8. Cut it in half, and that tells me to change by 4. So here's my midline. And again, changing by an amplitude of 4. On this next one, the number in front of the trig equation is your amplitude. So amplitude here is 3. Number in front here is a -5, but the negative actually just tells us that it's a negative sign graph. The 5 is our amplitude. So we want the greatest amplitude. We've got a 3, a 2, a 4, and a 5. So clearly the greatest is 5. Alright, next one says, consider the system of equations below. 2x minus y equals 4, and x plus 3 squared plus y squared equals 8. So I want to first get the equation right here in y equals. So I'm going to add y to the other side. but then I'm also going to get rid of that 4 by subtracting it. So this now looks like y equals 2x minus 4. And as soon as this is equal to y, I can now take this and plug it in wherever I see y. So we've got this x plus 3 that needs to be written out twice because it was squared. So x plus 3 times x plus 3. Same thing with the replacement for y. Now we have plus parentheses 2x minus 4, but that's technically squared because y was squared. So write it out twice. And then equals 8. So take a minute as I go through this on the video, try it on your own, just double distribute all the way through. And then I want you to combine like terms after you've done that. Okay, so I'm going to do it on the video while it's rolling. You should be doing the same work on your paper on your own though. Okay, so we've got 5x squared minus 10x equals, or sorry, not equals, plus 25 equals 8 once you've combined all your like terms. And then we want to subtract 8 from both sides. So then this gives us 5x squared minus 10x plus 17. Now we want to think about how to factor this. I don't think it's going to factor nicely. I'm just thinking quickly that if we try, let's see, 5x, 1x, and then multiplying to 17 would be 1 and 17. So try 17 here, 1 here. This is 17x, 5x. There's no way to make 10 out of that. Okay, so I'm going to ditch that and I'm going to try the quadratic formula. That will always work for you when you're solving a quadratic, even if it's one that's easy to factor. Remember, quad formula requires you to label A, B, C. And so now it's x equals negative b plus or minus square root b squared minus 4ac all over 2 times a. Okay, so we've got, let's see, x equals negative b, so negative 10 is positive 10, plus or minus square root, 10 squared is 100, minus 4 times a times c, all divided by 2 times a, so 2 times 5 is 10. I'm going to just carry my work over here. So we have x equals 10 plus or minus square root of some number all over 10. So I need you guys to type this piece into your calculator. 100 minus 4 times 5 times 17. I believe that gives you negative 240. So remember that when we have a square root of a negative, this means that we will pull an I out and then square root of positive 240. As soon as we pull an I out, our solutions are imaginary. And it's both of them because we have plus and minus. Alright, so question 20, we're just going to finish up this page and then you guys will be good to relax for a few minutes. So question 20 says, which binomial is not a factor of the expression? And then they give us this polynomial here. So if it were to be a factor, then when plugged in, it's going to be equal to 0. But if it's not a factor, wow, I'm really bad at boxing that in. Holy moly. Okay, so if it's not a factor, when plugged in, then the equation will not be equal to 0. So what I'm saying, when we plug it in, we have to first change this. This is x plus 2 as a potential factor, so that would look like x plus 2 inside parentheses. And then remember, when you take stuff out of parentheses, it goes to x equals negative 2, sign switches. So if I were to plug in negative 2, and you have to do this carefully into your calculator, it's negative 2 inside parentheses to the third minus 11 times negative 2, again in parentheses, that's the super important part, to the second, plus 16 times negative 2 plus 84. Okay, so take a minute to type this into your calculator, get an answer. I feel like I should play elevator music while you guys are typing this in, and I wait for you. Alright, so you should find that this is equal to 0. So that's actually not going to be our answer because we want this to not be a factor, so it should not equal 0. So we're going to try the next one. X plus 4 is the potential factor, so then when I take it out of the parentheses, we have x equals negative 4. So we're going to plug this in again. Parentheses, negative 4 to the third minus 11 times negative 4 to the second plus 16 times negative 4 plus 84. All into your calculator again. If you want to sing a song as you do this so that it's not so silent in the room, that's okay. As long as it's appropriate. So when I type this into my calculator, I got negative 220. So that's not 0, clearly. Negative 220 is very different from 0. So this is actually not going to be a factor. So choice 2 is our answer here. And last one, question 21. A ball is dropped from a height of 32 feet. So we start 32 feet off in the air. And it bounces and rebounds 80% of the height from which it was falling. What is the total downward distance in feet that the ball traveled up to the 12th bounce? So if you can imagine, this ball starts off very high in the air, hits the ground, bounces back up, hits the ground, bounces back up, hits the ground, and so it keeps repeating this pattern until it stops bouncing. So they want to know the total distance traveled. I know sometimes it's going back up, but we're just talking about how much it travels overall. Up to the 12th bounce. So this is actually a sum formula that is on your reference sheet. A sub 1 minus A sub 1 times R to the n, all divided by 1 minus R. Where A sub 1 is your initial amount, so we've got S sub n, total sum, that's what S is. A sub 1 is that initial amount, 32 feet, minus, again, 32 feet, times R. R is the rate at which we're going. So in this case, it's 80% of the height, so that's 0.8. Raised to the n. N is the number of bounces, so 12 would go here. All divided by 1 minus your rate. Okay, so go ahead and type this whole thing into your calculator. Make sure you pull up a fraction first, so control divide. Type the numerator in, type the denominator in, and get an answer. Alright, so I found choice 4. So hopefully at this point we're right around the end time for class. If you guys have a ton of time left over, then just please be respectful. Use the time to get some of your work done for other classes that you need. But thanks for paying attention. I'll see you next week, and we'll be back at it again, working through more of these practice problems, because remember that you guys only see me another 6 times after this before you take your test. All right, have a good day. See you later.